Hello and welcome back to Mech Zone. Today we shall be starting with a different type of approach that is called as assignment problem. Now, in the assignment problem, it is actually a special case of the transportation problem that we have already discussed in the previous lecture. Now, what we have to do here is we have to allocate the jobs to the specific or to the particular operators in such a way that the cost of assignment becomes least. And it also includes two types of problems, that is the balanced and the unbalanced problems. Now we are going to solve these problems only by one method, which is the best method, and it is known as the Hungarian method. So in the Hungarian method also we are first going to obtain the feasible solution and then we will go for the optimization. Now since the optimization is beyond solving in case of gate examinations, because there the time is very limited, so we will be concentrating more only on the feasible solution case, and optimization is generally not asked. So the problem will be given in a form of a matrix such that these are the jobs, that is 1 2 3 4 5, and these are the operators 1 2 3 4 5. So the different jobs have to be given to the different operators, and these are the times corresponding to these operators that they will obtain. For example, the first operator for the first job will take 9 hours or 9 whatever time units, and the second operator would take 11, third would take 14, fourth would take 11, and fifth would take only 7 hours. So these are the data or the times which are given in the number of hours or the processing time. Now the main aim is to assign the jobs to the operators so that cost is minimized and the work is done at the earliest possible time. If the number of jobs and the operators were not equal, for example, this is a case of a balanced problem, that means 5 operators and 5 machines. If it would have been not so, or the operators were not equal to the number of jobs, then we would have used a dummy row. Here we have used a dummy row such that each element would have been 0 in that particular row. Now the first step is to subtract the row minimum from each element. If we look in a particular row, we will identify which is the least element. In this particular row it is 7, for this row it is 6, then in this row it is 6, then for this row we have 9, and for the last row we have 7. So we have actually identified the least elements in the particular rows. Now what we are going to do is we are going to subtract 7 from each element in this particular row. We are going to subtract 6 from each element in this particular row. Subtract 6 from each element in this particular row. 9 will be subtracted from all these elements and 7 will be subtracted from all these elements. So after subtracting we will obtain this matrix. Now after applying the row minimum, we will now go for the column minima. So we will see what are the minimum values in a particular column. For this column we have 0. So first we are applying the row minima and then we are applying the column minima. In this column the value is 0. For this also the value is 0. For this column the value is 2. And for this column the value is 0. Now we will subtract the minimum value from each of the element. Now 0, when it is subtracted from all these, this will remain the same, this column will remain the same, this will remain the same, and this will remain the same. But when 2 will be subtracted from all these elements, we will obtain a different matrix. So what will be obtained here? When 2 is subtracted from that fourth row, we will obtain 2 5 0 1 1, and rest everything will be same. Now what we will do is we will apply the row scanning. In the row scanning, what we are doing is we are to draw the minimum number of lines so as to cover up all the zeros of the matrix. For row, we will draw the vertical lines. Please remember, it is the opposite. For row scanning, we will draw the vertical lines, and for column scanning, we will draw the horizontal lines. Now, for example, if we look in this row, here we have exactly 1 0. What we will do is we will square this 0. We will put a square around this 0. In the second row we are having this 0 and we will square it. So when we have drawn a square around this 0, we will cancel it by a vertical line. Similarly, for this 0, we will cancel it by a vertical line. Now in the third row, we have 2 zeros. What we will do is, we will skip this row. We will not draw any vertical lines when there are more than 1 zeros in a particular row. Now for the next row, we again have 0 here and 0 here. But this 0 was earlier being cancelled out. It was already cancelled out. So we will draw a square around this 0 and we will cancel this particular 0. Now when we come to the fifth row, this 0 was already cancelled when we have cancelled this entire column. So we see that number of squares 1, 2, 3. The number of squares that have been drawn are 3 here. And after the last row has been scanned, check whether all zeros are covered or not. Now after the row, we see that these 2 zeros have been left uncovered. Okay. Now since these 2 zeros were left uncovered, we now go for the column scanning. And for the column scanning also, now for the column scanning, we will draw the horizontal lines. So for the first column, if we see, this was already cancelled out because all the zeros were cancelled. So we are not going to draw horizontal line. For this column also, the 0 was earlier cancelled out. But when we come to the third column, it has only 1 0 and we will square it and this 0 will be cancelled out. Okay. And this row we have already cancelled it earlier. Now we will draw horizontal lines instead of the vertical lines when we are going for the column scanning. But when we were going for the row scanning, we draw vertical lines. Now all zeros have been covered. Now we see that all zeros have been covered either by vertical lines or by horizontal lines. Now we check whether the number of lines drawn is equal to the number of squares. 1 square, 2 square, 3 square, 4 square. Number of squares drawn are 4, but if we look at the lines 1, 2, 3, 4. Okay, so 4 squares and 4 lines, but the number of rows are 1, 2, 3. Total number of rows are actually 5. So the 4 number of squares and 5 rows, and these are not equal to each other. Okay, these are not equal to each other. Now what we will do is, now we will go for next step. Now what is that next step? Please listen carefully. We will identify those elements which are uncovered. So uncovered elements are 7, 2, 5, 7, 1, 1, 1, 7. All these elements are uncovered. Uncovered means they are neither covered by a horizontal line nor they are covered by a vertical line. So all these elements are uncovered. Now we will identify the least uncovered element, which is 1. Okay, least uncovered element is 1. What we will do is, we will add this 1 to the elements which are lying at the intersection of horizontal and vertical lines. So vertical and horizontal line intersection we have 6, vertical and horizontal lines we have 7, vertical and horizontal lines we have 2. So we are going to add 1 to these 3 elements only, whereas from rest of the elements we are going to subtract 1. So 7 minus 1, 2 minus 1, 7 minus 1, 5 minus 1, 1 minus 1, 1 minus 1, 7 minus 1 and 1 minus 1. तो क्या करेंगे हम, जो 1 है, जो लीस्ट एलिमेंट है, जो अनकवर्ड है, उसको इंटरसेक्शन एलिमेंट्स पे जोड़ देंगे और रेस्ट अनकवर्ड एलिमेंट्स में से हम उसे सब्सट्रैक्ट कर देंगे. और ये कब करेंगे? जब हमारे नंबर ऑफ स्क्वायर्स जो हमने ड्रॉ किए दैट is not equal to the number of rows that we have in the question. Now after applying that step, we will obtain this matrix. Now by looking at this matrix, we will again go for the row scanning and the column scanning. When we go for the row scanning, in the first row we have this 0. So we will square this 0 and cancel out this entire column. Now since we are going for the row scanning, we will draw the vertical lines, and when we will go for the column scanning, we will draw the horizontal lines. Now in this next row we have this 0. So this 0 is squared and this entire column is cancelled out. For the third row we have 2 zeros. So we will, for time being, we will neglect this row. Now for the third row, when we come, we will also neglect this row since it is having more than 1 zeros. But when we come to the last row, it is also having 2 zeros, so we will neglect this. Now we go for the column scanning. For the column scanning, we see that it has 2 zeros. But initially when we were doing the row scanning, this was already cancelled out. Now when we come to the second column, we have this 0, which is the only 0 in this column. So we will draw a square and we will draw a horizontal line. Now all these zeros have been cut. When we come to the third column, we already see that it was cancelled earlier. For same with the fourth column and same with the fifth column. Now we will count the number of squares. 1, 2, 3, 4, 5. And the number of rows were 1, 2, 3, 4, 5. Now the number of squares drawn are 5 and the number of rows are also 5. When this state has been achieved, we will say that we have obtained the feasible solution. Now how to represent the feasible solution? The squares which have been drawn indicate that first job is given to the fifth operator. Second job is given to the first operator. Third job is given to the third operator. Fourth job is given to the second operator. And fifth job is given to the fourth operator. So I have written this here. Now if we look at the initial matrix which was given as the question form, so we will now compare these positions and we will find out the time correspondingly. This position is having a time of 7. So I have written 7 here. This position is having a time of 6. So I have written 6. This position is having a time of 6. So I have written 6. 6 and 6. Now this position is having a time of 9. So I have written 9 here. And this position is having a time of 10. So I have written 10 here. Now the total time that would be obtained is 38 hours. And these time will be found out from the initial matrix that was given in the problem form. Now these values are taken from the matrix in the question. So after the feasible solution has been obtained, we will say that the total time would be 38 hours. So the assignment can be done in 38 hours and this is the optimal solution. So with this we come to the end of our lecture. We hope that you are enjoying our lectures. Please give us your valuable feedbacks. We promise that we will revert back to your problems asked on our YouTube channel or on our Facebook page. You can search it on Facebook also. We are there on Facebook by the name of Mech Zone, and you can post your problems there. All the study material is available absolutely for free. You can download it and study. All the video lectures are also available absolutely for free. You don't have to spend even a single penny for that. हमारे चैनल के बारे में अपने फ्रेंड्स को भी बताइए so that they can also be benefited, and we will also be providing ultra short and micro notes for ultra quick revision, but that would be done in the month of January because those notes will be helpful for very quick and fast revision. So with this we come to the end of this lecture. We hope कि आप हमारे चैनल को सब्सक्राइब करेंगे, हमें अपने वैल्यूएबल फीडबैक्स देते रहिए, हमारे चैनल को लाइक कीजिए, कमेंट कीजिए एंड शेयर कीजिए. सो थैंक यू ऑल फॉर टुडे.